Hello everyone, my name is Nicolas and today we are going to present you OYT, the track-guided robot. We are going to go over a brief introduction, talk about the development, software and hardware-wise, talk about some applications for our product, and also show and conclude with a small demo. I believe everyone knows, but we always had like a close bound to tracks. It all started like long ago with wagonways, to carry out gold from mines. And then after the first industrial revolution, we basically started using a lot more, not only to carry people, stuff, but also people. And we want to take this one step further, as my colleague Leonardo will show you.
Hello everyone. So what exactly are we trying to do here? Our main idea with OYT is to create a robot which is able to follow a line and make some action, like for example make measurements or transport an item. It shouldn't be really expensive, and it's very important that it's easy to set up and reliable. As we look into the movies and the culture, we have a lot of examples of robots that do this kind of things. Like for example, in the left we have a robot from WALL-E that just follows a line and cleans the dirt. We have in the right upper right, we have a robot from Star Wars. There is a repair unit. We also have this chair from WALL-E that just carry a person around the spaceship following the line. So Nicolas talk about the importance of railroads and tracks in the history of humankind. And now I talk to you about the movies and science fiction. Well, this is not science fiction anymore. Ladies and gentlemen, I present you OYT, on your track robot. OYT is a completely autonomous robot. It follows a line, can make measurements, and transport items. It also has a wirelessly connection with a computer where it can send data. So now my friend Rodrigo will present the development, the hardware part.
All right, guys. Good afternoon, everybody. We'll talk a little bit about the hardware of our robot and the circuit. Basically, we use the Arduino Nano. The main purpose to use the Arduino Nano is the size. And even though it is like 1/4 of the size of Arduino Nano, it has the same processing power and the enough outputs, inputs, either analog or digital. It's perfect for our project. As input sensors, we have 8 infrared sensors and 1 ultrasonic sensors. The infrared sensors are used to identify the path, and the ultrasonic to identify some sort of obstacles on the path. So the Arduino use all these input data to control 2 DC motors. These 2 DC motors make the robot moves to the right path. And we also used one XB to establish a wireless connection, so we can like send data and receive data through other devices or a computer, for example. In this project, we developed a PCB design, a PCB board for the project and circuit. The purpose of that was if we build all the circuit in breadboards or boards for the prototype, and as this device is like moving all the time, we would have like a lot of problems with bad connections and this sort of stuff. And also to show, this is a prototype, and to show clearly all the components of our robot. So we designed in an understandable way, so you can just look at it and see all the sensors, the motors, and all the components of the circuit. I will talk, as the key point of our project is to follow the line, I will just explain a little bit more about the infrared sensors that they recognize the line. So these black cubes, as you can see on the picture, it basically is a LED, infrared LED, and a phototransistor. This phototransistor sends the light that is reflected by the surface. depending, different surface will reflect different amount of light. So this sensor can, the Arduino sense this different intensity of light, and then we can differentiate colors, different surfaces, and as you can see, that black and white is our path. We are using like just 2 colors, but because this is a small and simple example of how our robot works. But we can also use like different colors to develop like a more complex system. Now my teammate Pedro will talk a little bit about the software part of our project. Thank you.
Good afternoon. One of the most difficult parts of the artificial intelligence is to figure out how the environment changes. OYT is able to detect these changes in the environment and do its job. The software is divided in 2 parts, an embedded software implemented on Arduino and an external software implemented on MATLAB. The embedded software implemented on Arduino is able to read the sensor's data and figure out the actions that the robot must do. The embedded software is also able to send and receive data for an external application. This external application is implemented on MATLAB, and this application is able to send and receive data in real time and plot this data provided by a sensor in the body of our robot, and plot this data for the user of the application. There are many applications for this robot. A good application, a good example for this robot is in a hospital, for example. In a hospital, it is quite difficult to implement change in the environment and keep the hospital operations at the same time. With this prototype, we can simply draw a line on the floor and spread some sensors in the environment in order to communicate with the robot. A doctor, for example, can send a request, for example, OYT, bring me a medicine from the point A to the point B. For example, the point A is the pharmacy of the hospital, and B is the doctor. Now, my friend Igor will present a small demo of our prototype.
Hello, everyone. As we need more room to provide you with a live demonstration, we decided to put it in a video to show you how our device works. So, as you can see, we don't need any tracks. We just need a paper-printed line, paper-printed track, so the robot can follow it. And you can also program it to recognize different patterns in a track, so you can perform different actions according to the pattern of your choice. It is also a great feature because with just a simple circuit in a printed PCB, a small printed PCB, just some regular components that you can easily manage, easily use, and a lot of hours of hard work and testing, and we could build this device, this completely autonomous and capable device, completely reliable device, and we want it on your track. Thank you.
Don't